Howdy and good day. Today we're in Algebra, we're covering CO2, estimating the root of a non-perfect square. We kind of introduced perfect squares and non-perfect squares yesterday when we talked about rational and irrational numbers. Today we are going to focus on estimating those values of non-perfect squares. But we start with defining a root. What is a root or a radical? Yes?
A root is the base number or something?
Base number, okay. If we were to describe how to find a root or a little bit more than what are the characteristics of a root? That's kind of what I'm looking for here. Yeah.
Oh, shoot.
You were stretching.
Yes.
Yeah, that happened. Nick.
A number divided by
Itself.
wait, never mind.
Okay, fair enough. Sebastian?
A number that can be divided by two numbers that are the exact same.
Okay, I'll rephrase that a little bit. A root is a factor that, when multiplied by itself, equals the given number. Okay? It's a factor that, when multiplied by itself, equals the given number, or the number that we are taking the square root of. So, if I ask you for the root of 36, 36 has several factor pairs, right? It's got 3 and 12, it's got 4 and 9, 6 and 6 though, right? That factor that when multiplied by itself equals 36. So the root of 36 would be 6. Okay? The root of 100 would be 10. The factor that when multiplied by itself equals the given number. So then we move into, okay, we've got perfect squares and non-perfect squares. Yes, Luke?
I was going to say something for perfect squares.
Go ahead.
So perfect squares are just anything that can be multiplied by itself to get any given number.
Okay.
So like, for example, 16.
So 16 is a perfect square because 4 times 4 is 16. Okay. We're going to define perfect square and non-perfect square, we're going to relate it back to rational and irrational numbers. A perfect square has roots that are rational, like 16. The square root of 16 is 4. 4 is a rational number. Root 36 is 6. Root 100 is 10. Both 6 and 10 are rational numbers. Whereas non-perfect squares, they have roots that are irrational. Like in root 12 and root 8, the two examples that you had in yesterday's homework, root 12 is not a perfect square. There's no factor that when you multiply it by itself gives you 12. Therefore, if you took a root of 12 in a calculator, you're going to get, like 3.3 blah, 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 blah. Okay, it goes on and on and on. Same thing with root 8. Those irrational square roots. Yes? All right. Questions so far? I'm going to erase this and scroll down to fill out the table. So if you are still jotting these notes down or have questions about these definitions, now would be a good time to ask. No? Very well. Pen down, then clear the ink, then scroll down perfectly. Woo, look at that. It worked. So this table here that we're going to fill out is going to aid us in identifying perfect squares, which will then help us evaluate or estimate non-perfect squares. Okay, so 4 is a perfect square, and the square root of 4 is 2. Not 16, that'd be 4 squared, right? The square root of 4, the root being the factor that when multiplied by itself equals 4, that is 2. The next perfect square is 9, and the root of 9 is 3. Then comes root 16. The root of 16 is 4. Root 25 is 5. Root 36 is 6. Root of 49 is 7. Root of 64 is 8. Root of 81 is 9. Root of 100 is 10. And now they start to get a little more fun. What is, yes, I said fun. What is 11 squared? So, well, if you have to, but root of 121. How about 12 squared? 144. 13 squared? Anybody? Sebastian? 169. 14 squared. 196. 15 squared. Anybody? Alan? 225. Folks. Shh. And 16 squared. 250 what? 256. Okay? It will greatly behoove you to memorize these perfect squares up through 256, simply because as we get deeper into the maths, and we use kind of square roots and exponents more frequently, if you just have these values banked, you don't always have to go to your calculator. It's just going to make things go more efficient and more quickly. So this is being a definition or a key point. This can go on a help sheet. Since you will not be able to use your calculator on this objective for the test, I think this might be a helpful tool for you. Well, if you can use your calculator, all you have to do is type in the numbers. You could train a monkey to do that. I mean, come on. No, that's much less cool. Okay? So, someone go ahead and give me a number between 4 and 256 that is not a perfect square.
255.
A different number than that. 5. Let's. Okay, fine. Between 50 and 200, that's not a perfect square. Just yes. That is a Last one. I believe in you, Luke.
Okay, 79.
Thank you. Okay. So, if we are asked to estimate the value of 79, 79 being prime, especially, does not have a pair of factors that is something times itself. So what we do is we look up here and we say, okay, what two perfect squares is 79 between? You know what? Those types of comments about Alan, those are the things that we don't want the video to pick up. Okay? Because now we can say who is disrupting. And so those are the types of comments. Ask your questions. The banter's fine, but those sorts of things we want to avoid. So anyway, back up here. So the root of 79, what two perfect squares does the root of 79 fall between? What's the next smallest perfect square? What's the next largest perfect square? Griffin. What's that?
8 and 9.
Well, okay, so root 64 and root 81, which have values of 8 and 9. Yeah, that's figured. So because root 79 is between root 64 and root 81, and the root of 64 is exactly 8, the root of 81 is exactly 9, we know that the root of 79 must fall between those two values. Okay? Well, here's where we're going to get a little more specific. Right in the middle of this is 8.5, but is 79 right in the middle of 64 and 81? No. Which number is it closer to? 79 is closer to 64 or is it closer to 81? 81. Which means that it's going to be closer to 9 than it is to 8. Okay, so if you estimated this to be 8.5, you'd be telling me that it's right in the middle of 64 and 81, but it's clearly much closer to 81 than it is to 64. So you could estimate this as being 8.8, 8.9, maybe even 8.7, but that'd be a little bit low. Oof, I don't know. That's getting a little bit crazy. Okay, going to the hundreds place. Oh boy. Okay, so that's kind of the process that we're using here to estimate these square roots. We're using the perfect squares we know to give us kind of guidelines, and then we're filling in the holes. Okay? Questions on that? Okay. Let's do a number between 100. Yes.
So, pick a specific one.
Well, I'm giving you the homework here are the ones that. What do you mean by pick a? For the answers? No, you could write either of those, or you can pick one. Either one's fine. Okay. It does say that you can check your answer using a calculator. So if you type in root 79 in your calculator, you're not going to get 8.8 or 8.9. You'll probably get 8.8 blah 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 blah. Okay. But that would be close enough for an estimation, right? We're only going to the tenths. 8.8. There you go. Luke, question?
Oh, I was gonna say I wouldn't.
You give us the last one. We'll let someone else. Nick,
21.
between 100 and we'll say 250, please.
250.
Sure, why not? Okay, so the root of 250. That's all the way at the right side of our table here. We're looking for the perfect squares that are below 250, the one that's next below, the one that's next above. And we look and we see that 250 is going to be between 225 and 256. Because we know the values of 225, exactly 15, and 256, exactly 16, we know that the root of 250 is somewhere in between 15 and 16. So then now here's where, again, we look, okay, 15.5 is exactly in the middle here. Is 250 closer to 225 or 256? 256. Therefore, its decimal value will be closer to 16 than it is to 15. Again, we're kind of looking at probably 15.8, 15.9, somewhere around there, 15.7 even perhaps. Okay? So that's what we're doing today. In your homework, I don't want to see just a decimal number here because I don't know if you use your calculator to find that or what have you. I need to see this work. Okay? Tell me what two perfect squares the non-perfect square is between. Break it down. Tell me which one it's closer to. Kind of exactly what I have up here is what I want to see on your paper for work. All right? Pick one from the top row that you want to explore. Camden.
140.
The root of 140. Ooh, pen down. There we go. Okay. Root of 140. What are the perfect squares on either side of it? What's the next smallest? What's the next largest? Luke?
11 and 12.
Root 121, which is 11, and root 144, which is 12. And because root 140 falls between those two perfect squares, we know that its value falls between 11 and 12. If you ever have a number range that's greater than 1 here, like if you had 11 to 13 or 10 to 12, something like that, then you've missed a perfect square somewhere. This should always give you a range of just one number, so you can put the half in there, 11.5, and narrow it down from there. Okay. 140, once again, closer to the greater perfect square, closer to 144. So its value is going to be closer to 12. I promise you not all answers will be like 0.8, 0.9, But that's what we get again here, 11.7, 11.8, perhaps 11.9. Either one would be acceptable, because again, this is an estimation here, right? Okay. Did I see a hand up over here somewhere? No? Okay. One from the bottom row that you would like to discuss. I bet I can predict which one you're going to say. Yes? Yes, negative root of 215. For starters, there is a difference that the position of that negative sign matters. There's a difference between what we have here, the negative root of 215, and the root of negative 215. You know, in one of these, the negative sign is outside of the root, and in the other, the negative sign is inside the root. Negative root 215, what you have written, you can do that. Okay, and in fact, the process to estimate it doesn't change, except for when you're all done, your answer is just going to be negative, right? With the negative sign inside the root, that's mathematically illegal to do until you're in Algebra 2. So you will learn about how to deal with the root of a negative number in Algebra 2. If you put that in your calculator, the root of negative 215, with the sign inside the root, it's going to give you non-real answer error, I believe it says. Or domain error, something like that. Yeah. If you care, I can explain to you what the root of a negative number is. Okay? So the square root of 9, whoever's whistling and humming, we can stop that. The root of 9 equals 3 because 3 times 3 equals 9, right? That's the definition of a square root. What times itself equals 9. But if I ask you for the square root of negative 9, well, the answer is not 3 because 3 times 3 isn't negative 9. The answer is not negative 3 because negative 3 times negative 3 is positive 9. And the only way to get negative 9 is 3 times negative 3, but that's a problem because that's not the same thing. So when mathematicians were posed with this problem, they did what, probably your parents used to do when you would ask them questions they didn't know the answer to. They just kind of made something up. Okay? And what they made up is that, well, it's not actually 3, so we're just going to imagine the answer is 3. And if you've ever seen that little lowercase I in math, it means it's an imaginary number. We are imagining the square root of negative 9 is 3.
So that's the answer, so it's really simple.
Yes, the root of negative 9 equals 3i. The root of negative 16 would be 4i, right? But you don't start to apply that until Algebra 2. And so that's why right now I say you can't do it, because we're not going to deal with it yet. But that's, if you were to see it on a map test or something like that, that's what the answer would be. Yes?
I have a question.
Yeah.
Just out of curiosity, can you check after you've finished everything to see if your estimates were...
On the homework, yes. On the test, no. She asked if you can check your answers using a calculator. On the homework, yes, I encourage it. On the test, no. So anyway, back to the question at hand. Sorry, a little bit of a tangent there. But the next, my point here with the negative root 215 is you can essentially ignore the negative sign, do the work, and then stick the negative sign back on your answer when you're all done. And that's okay.
Really?
It is. So we've got root 196. Whoops. Oh, what did I do now? Hold on. I don't want that. Okay. I think so. So root 196 and root 225, that gives us 14 and 15. And because 215 falls between those two values, we know it's going to be somewhere between 14 and 15. This one's a little bit closer. It's 19 away from 196, only 10 away from 225. So once again, when we think about half here, it is going to be closer to the 15 than it is to the 14.
I think I've seen a pattern.
It's just the ones that you've picked. Some of them, a lot of them go the other way. But so this one, if you wanted to call it 14.6, 14.7, 14.8, either of those would be fine. Although because we want the negative root of 215, make sure you put your negative sign back on there. Negative 14.6, negative 14.7, negative 14.8. Either of those would be okay. Okay? Yes?
Well, then I want to see proof that when these on here is actually under 5.
They do 11 or 51.
That one,
Prove it to me.
that one.
Well, prove it to me. Prove it to me.
No, I
No.
really did 51.
I don't know where I'm going to over this.
I already
Prove it
did
to me. I need to see this.
You prove it to me, and we'll talk about it tomorrow.
Well, you guys got
3, 2, 1, you are quiet. So your homework are these 8 questions here. We've already done 2 of them, so you have 6 to do on your own. Do not forget to be showing your work. Again, if all I see is a decimal answer written without any work shown, I can't give you credit for it. The question down here at the bottom, the real world application, this is part of your homework too. It says, through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot of land to be a square with an area of 200 square miles. The length and width of the plot, however, have faded because the map's old. Approximately how many miles long and wide is the plot of land? So what we have here is a square with an area of 200. So what you need to do is think about, what do I know about squares? What do I know about the area of a square? And since we're talking about the concept we're talking about today, how does that kind of apply to the concept at hand? Okay, and your job is to tell me what the length and width, or how many miles long and wide is the plot of land. Okay? Shh. I don't remember calling on anybody. So, McKenna.
The answer would have squared in it though, right? Or like when you're doing that.
The answer would not have units squared because you're giving me lengths. Okay? Length and width are just single unit measurements. Yeah. The answer will be a decimal. Just to the 10th is fine. All right. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms on CO2?
Well, that was a lot of work.
Yes.
I don't think congratulations whoever got that much land.
Well, thank you. Okay.
Oh,
All right, folks, pressure's now on you. That's how you math.